Hey there everybody, Mr. D here, and in this video we're going to be talking about how we can write the equations of lines in slope-intercept form given certain bits of information. If you are ever given 2 points on a line, you have enough information to calculate the slope, which means you also have enough information to get the equation of the line. If they give you the slope, then that's just one step already done. There are a few formulas that we'll need to use along the way here, and I'm going to kind of zoom the screen in so I can get those written out. I would strongly advise you guys get these jotted down somewhere as well. So I'm going to really zoom in. All right, so the formulas that we're going to want to use, first and foremost, is going to be calculating slope. If slope is not given to us, we have to calculate it. And the slope formula, you guys have seen this before, is going to be the change in y, so y2 minus y1, over the change in x. x2 minus x1. And you can calculate this if you are given 2 points, x1, y1, and x2, y2. The next formula we're going to talk about and use is going to be point-slope form. So point-slope form is the equation of a line in which you know 2 items. You know 1 point that's somewhere on the line, and you know the slope of said line. So we already know the slope, and we're given just some random point. We'll call that x1, y1. Point-slope form looks like this: y minus y1, so this value right here goes in for y1, equals m times the quantity x minus x1. So m is the slope, and then x1 is just whatever point came from there. Once you have something written in point-slope form, it's relatively simple to translate this into slope-intercept. Remember slope-intercept being y equals mx plus b. It's probably the most user-friendly graphing format. And to transfer this, all we'd have to do is distribute our slope into the parentheses there, and then take whatever this y1 was and throw that to the other side. So those are the 3 formulas that we're really going to be hammering in. So make sure at some point, somewhere, you have these available to you for reference. All right, here we go. We want the equation of a line that has an x-intercept of 4, 0, and a y-intercept of 0, comma, negative 3. Well, hey, they gave me a y-intercept. They just gave me the b value in y equals mx plus b. So that's awesome. I know that that b value is going to be 3. So really, I just need to figure out what's the slope. Well, let's use our slope formula up here. The change in y's over the change in x's. My y2 value would be negative 3 minus my y1, which is 0. If I call this x1, y1. Oh, goodness, that's supposed to be y1. Over here, this would be x2, y2. So negative 3 minus 0 all over the change in x's, 0 minus 4. I would get negative 3 over negative 4. So my slope is 3/4. Well, I know my slope. I know my y-intercept, which means I know slope-intercept form. Y equals 3/4 x plus 3 shadazy. All right, next one. We have a line that goes through the point 5, negative 8, so they gave me a point, and has a slope of negative 4. Well, I've got a point, and I've got the slope. Logic tells me point-slope form. So in the interest of saving myself some time, I'm going to plagiarize myself. Is it still plagiarism if it's my own work? Never understood the rules on that. So let me copy that over. All right. So they told me a point to use. They told me the slope to use. So really I just have to plug in my values and then rearrange as needed. So we're going to have y minus a negative 8 well, that's really y plus 8, equals my slope. What was my slope? Negative 4 times the quantity, x minus the x1 value, in this case was 5. So we'll clean things up. We'll distribute that negative 4 in there. So negative 4x, this would be a positive 20, so plus 20. Y plus 8 equals negative 4x plus 20. And then we want y by itself, so we'll just kick the 8 to the other side. Y equals negative 4x plus 12. Shazam, we're done. All right, number 3. They gave us 2 points. We don't know the slope though. Gosh dang it. Well, if they give me 2 points, I can calculate the slope. And as soon as I know the slope, I can use point-slope form. So this is certainly very doable. First thing we need to do is calculate the slope. So I'll use my slope formula, the change in y, so 1 minus 5, y2 minus y1, over the change in x, x2 minus x1. If we simplify, I get negative 4 over negative 2. Well, that just equals a positive 2. So my slope is positive 2. And now I can go straight into my point slope form, where it was y minus y1 equals slope times x minus x1. And I have to choose either one of these 2 points. It doesn't matter which one. I'm going to choose this one because why not? Doesn't matter which one I choose. The y value is 5, so y minus 5 equals 2 times the quantity x minus x1, in this case was 3. So let's solve this out. Distribute the x in there. Apparently I'm writing with a highlighter now. We get y minus 5 equals 2x minus 6. Add 5 to the other side. And I'm getting y equals 2x. That'd be minus 1. Now this process would still work if instead of using 5 and 3, if we did 1 and 1, so 1 here and a 1 here, you'd still get the same answer because this would be 2x minus, in this case, 2. So y minus 1 equals 2x minus 2. And then we'd still get the final answer being the same when all is said and done. Last and final problem. All right, here they don't give us anything. They just give us a graph. So we don't know slope, although we can figure it out. And they didn't give us any points, but I'm seeing a bunch to choose from. First and foremost, I don't know my y-intercept. I'm going to guess it's going to be negative 3 point something, but I don't know for sure what it's going to be. So I don't want to just kind of take a stab in the dark. You should never stab anything in the dark, by the way. But let's go ahead, let's get our slope. So it's going to be positive. If I go rise over run, we go up 3 over 2. So up 3 over 2 is my slope. And then I'll use this point right here as my x1, y1. That is the point 3, 1. The reason why I'm choosing this guy as opposed to any one of these is this doesn't have any negative values. And if I can avoid negatives, I like to. It's one less thing to worry about. So now we'll take this information, we'll throw it into point slope form. I've got y minus my y1, in this case 1, equals m, 3/2, times the quantity x minus x1, in this case x1 was 3. We'll distribute on the right-hand side. So this will be 3/2 x minus, well 3 is technically a 3 over 1, so 3 times 3 is 9, over 2 times 1 is 2, so 9/2. And then I need to add 1 to the other side. But if I'm adding 1, I need common denominators. So adding 1 is the same thing as adding 2/2, 2 over 2. So instead of thinking of this as adding plus 1, I'm going to say plus 2/2, so 2 over 2. When I do that, I'll get y equals the 3/2 x minus, let's see, negative 9 plus 2, that'll be negative 7. So 7/2. 7/2 is 3.5, and if I look at the graph, I'd say the y-intercept 3.5. That seems pretty accurate. All right, if you have any questions, let me know. Good luck, have fun, be safe, roll tide.